Looking at chord rules today. Chords do sometimes get a little bit crazy, but we are trying to avoid some of the weirder aspects of them for our stay-at-home learning right now. We've got 4 rules we're going to look at in the same circle or incongruent circles. 2 minor arcs. These are, the minor arc would be this AB and this CD, are congruent if and only if their corresponding chords are congruent. A chord is a segment within a circle that has its endpoints on the edge, like AB here and CD. A diameter is a special kind of chord, but those are what chords are called. So we've got here, it says AB with the arc marking is congruent to CD with the arc marking, if and only if the chords, which are chord AB, which is a segment, congruent to chord CD, segment bar. So the arc is the curve and the chord is the segment. If one chord is a perpendicular bisector of another chord, then it is a diameter. So like if SQ is perpendicular bisector of TR, then SQ is a diameter. In the same circle or in congruent circles, 2 chords are congruent if and only if they are equidistant from the center. How you'll know is you'll need to have this right angle marking to tell that they are measuring that distance straight to that chord. They have here if AB is congruent to CD, if and only if EF is equal in length to EG. If a diameter of a circle is perpendicular to a chord, and often they will only draw in this piece of the diameter, which makes us use this rule, but really it's sort of in disguise. But if you have a diameter or part of a diameter that makes a right angle with a chord, it is bisecting the chord, splitting it equally, and also the arc. So it would mean that this chord FH piece and the HD piece would be equal, and that the arc FG and the arc DG will also be equal. So this is arc DG and arc FG. So here it says find the length of BD. Notice that you have a diameter AC. You have this right angle marking. That means that the chord is split evenly, meaning that if FD is 6, that BF is also 6. That means that BD will be 6 plus 6, 12. Over here, we have the congruent markings showing us that these chords are equidistant from the center, and what that means is that the chords are congruent and so are the arcs. So this arc here is equal to this arc over here. So my strategy for this one is to take the whole circle 360 minus the 106 that we have out here, and then that will give me 254. And then I'm going to divide that in half, which gives me 127 for each of these. And that means that 10x minus 23 equals to 127. And then I'm going to solve for x. So I'm going to add the 23 and divide by 10. And that gives me 15. For this one over here, it says find the radius and the measure of arc AB. We're not doing the measure of arc AB part. We're just going to find the radius. So notice that there's no radius even drawn, so you would want to draw one in. So like from C to B there. That gives us a right triangle, so we're going to be using Pythagorean theorem. Remember that this is a piece of a diameter, and if it's making a right angle to a chord, then it splits the chord evenly, which would make each piece of that 12, making this portion of the triangle 12. So we're going to do Pythagorean theorem. 5 squared and 12 squared equals c squared, which would give us that c is 13, making the radius 13 feet. Here we have another one, and often they will give you a radius in a weird spot of the picture because they don't want to, to give you too much information. We need to use the radius, but we need to put it in a place where it's useful, and to do that, we're going to put it right here, which will create a right triangle. And we'll have a right triangle where we have a leg of 2, an unknown leg, and the hypotenuse will be that radius. So we're going to do Pythagorean theorem here, which is going to give me that b squared equals 5. So b is the square root of 5. So this portion of this triangle is square root of 5, and x is double of that. So x is going to be 2 root 5. Next one, we have again been given a radius in a weird spot, and we're going to move it to a place that will be more helpful. So I'm going to move it right here, 13.7, and this 11.9 can go here. And so we're going to do Pythagorean theorem again with 11.9 squared plus b squared. So this is going to be like b, this part here, equals 13.7 squared. And this will give us that b squared equals 46.08 when we do 13.7 squared minus 11.9 squared. And then when we square root that, we get that b is about 6.8. So b is 6.8 in length. But this entire segment, because we want to find x, which is a piece of this segment, this entire segment is a radius, which we know is 13.7. So what we're going to do is 13.7 minus 6.8 to get the value of x, and that's going to be 6.9. And that's all the chord type problems that you're going to see.